Welcome to the new session of the course of differential equation. In this session, we will discuss about the applications of the differential equation. In this applications of the differential equation, firstly we will discuss about the orthogonal trajectories and how to find the orthogonal trajectories of a differential equation or the corresponding to a curve. We can have f of x y c is equal to 0 is a curve. Based on that, we are able to find out another curve that is very perpendicular to this curve. That means, the tangents of both the curves at a particular point, they are perpendicular. So, on that case we can say that both the curve is orthogonal trajectories of one another, and that is one of the applications of the differential equation. And also we will discuss in this application about the growth and decay, and also one more application of the first order differential equation is Newton's law of cooling. See we already heard about discussed about the family of the curves. See, suppose we have the family of the curves given by f of x y c is equal to 0. As we all know, what is f of x y c equal to 0 is actually a expression, mathematical expression in x y and an arbitrary constant c, and I just take that as an equation number 1. In that equation number 1, we will take another family of the curve g of x y k is equal to 0. As we discussed just before, f of x y c is equal to 0. Here it is equal to g of x y k is equal to 0 is an expression in x, y and k. Here k is also a arbitrary constant. We consider this equation 1 as f of x y c is equal to 0 and equation 2 as g of x y k equal to 0. We can say that f of x y c is equal to 0 and g of x y k are the orthogonal trajectories of each another if it is the intersection of the curves of the family f of x y c is equal to 0 with the curve of the family g of x y k equal to 0, their tangents of the curves are perpendicular. As we just discussed before, the tangents of the curves are perpendicular. Therefore, we can say that these two families of curves that always intersects perpendicularly. We can say that both the curves are always intersects perpendicularly. Come to the point of the orthogonal trajectories that we just discussed now. We can move to an example. Consider the family of curves. See, dear students, consider the family of curves f x square plus y square is equal to c or c square is the representing this one equation of a circle. This is the equation of the concentric circle centered at origin with radius root c, as according to while we are taking here it is equal to c is representing the set of all circles, concentric circles centered at origin with radius root c, and we can consider y is equal to kx, that is another family of the straight lines passing through the origin. So, we can say that these two are the orthogonal trajectories of each other. Consider, see, this is these circles are the concentric circles. So, these are the concentric circles x square plus y square is equal to root c, and this is c the straight lines, these dotted lines are the straight line passing through the origin. See, consider you can draw a tangent line perpendicular to this line, that is the tangent line to this point, that is very perpendicular, very much perpendicular to the line y is equal to kx. So, we can say that the orthogonal trajectories of the circles centered at origin with the radius root c are the set of all straight lines passing through the origin are the this one orthogonal trajectories. So, our thought is that how can we find the orthogonal trajectories? By using the concept of the first order derivative. See, to find the orthogonal trajectories of the family of curves f of x y c is equal to 0, we have in step 1 we can say that we differentiate the given equation. See, here we have the equation 3, that is the curve in the plane, that is f of x y c is equal to 0. Firstly, in step 1 we will differentiate this curve. So, we can differentiate by differentiating this we will get another equation, that is we will get a differential equation corresponding to the curve. So, we will get the differential equation corresponding to the curves, and we will get another curve with the derivative, that is g, we can say that g of x y dy by dx c is equal to 0 is the another differential equation. So, here see we already have the see here, we already discussed here in this curve it is there, c come to equation 3, here we have a c is here from c 3 and c I just give me here read as this is equal to 0 from 3 and 4. See, my dear students, we can eliminate the c and we will get the value of c, and by applying the value of c we can eliminate that c, so that we will get the equation of curve as in equation in x and y, and as well as we will get the differential equation as equation in x y and dy by dx. Okay, fine. Now, the next we will get f of x y dy by dx may be equal to 0. So, we will get the another family and we can replace. As we discussed here, actually our thought is that our aim is to find the orthogonal trajectory of a given family of curves f of x y c is equal to 0. See, my dear students, to find the orthogonal trajectory of given family of curves, our aim is to find the orthogonal trajectory of a given family of curves. We know that the orthogonal trajectories are those family of curves who are both of their tangent lines on a particular points they are perpendicular. See, so that actually we have their slopes, the product of their slopes is equal to -1. So, slopes at a particular point is we can say that that is the derivative of that point. So, dy by dx is the slope of the first curve. So, the product of the slopes may be equal to -1. So, the next curves whose slope is equal to -1 by dy by dx. To find orthogonal trajectory, we just replace dy by dx by -1 by dy by dx in the equation. See, f of x y dy by dx reread here at is equal to 0. So, see that is equal to 0. So, that we can say that we have here this is the value. So, we will have another equation f h of x y dy by dx is equal to 0 is there. H of x y dy by dx is equal to 0. So, that we will have h of x y dy by dx is equal to 0. So, we will get another equation while replacing we just we got another equation, that equation differential equation, that differential equation is obtained by replacing dy by dx by -1 by dy by dx. That is the first order differential equation. We can solve that differential equation, so that we will get a new family of curves. That family of curves is corresponding to the differential equation h of x y dy by dx is equal to 0. That equation is corresponding to h of x y dy by dx is equal to 0. So, that we can say that based on that h of x y dy by dx is equal to 0. So, see we will get like this. The curves will come like this. See, here consider the blue lines. The blue lines are the original curves that is given by the question, that is f of x y c is equal to 0. Corresponding to that curve, we will have for each and every point there is a corresponding to this point you can draw a tangent line. So, with the slope as dy by dx. So, can see the red lines, red curves are the these are the orthogonal trajectories for the blue curves. See, here while drawing the tangent line to this particular through this particular point, definitely we will get here is these two tangent lines are perpendicular. So, that we can say that they are the orthogonal trajectories. See, this is the general solution of the 6. See, I would like to I will tell you the 6 is the h of x y dy by dx is equal to 0 is there. So, whose solution is actually the required orthogonal trajectories. So, my dear students, actually what we done here in this step 1, come back to our system, we will have the system of equation as we will have the system of equation as f of x y is equal to 0 are the family of curves, and from there we can find differentiate with respect to x, we will get a differential equation corresponding to that family of curves, and we can eliminate c. After eliminating c, we will get a new equation f of x y dy by dx is equal to 0. Again you can replace this one dy by dx by minus 1 by dy by dx. So, we will have new differential equation that is equal to h of x y dy by dx is equal to 0. From there we can solve that differential equation. Finally, we will get the orthogonal trajectories for given family of curves f of x y c is equal to 0. See, I would like to invite your attention to the example. Find the orthogonal trajectories of family of the straight line through origin. See, my dear students, while moving to solution, we have family of in this given question, find the orthogonal trajectories of the family of straight lines through origin. That is y is equal to kx are the family of curves. That is y minus kx is equal to 0. See, we already discussed this is that x square plus y square equal to c has the orthogonal trajectories are y is equal to kx. See here we took it is that family of straight lines passing through the origin, that is equal to y is equal to kx. So, definitely we can say that their orthogonal trajectories are the concentric circles. Circles about the origin. So, my dear students, we can move to the question. So, we can find here we have given the family of curves are y is equal to kx. So, to find orthogonal trajectories, we will move to step 1. In the step 1, we can differentiate this one 7th equation, that is equal to y is equal to kx, where dy by dx is equal to k. See, we got dy by dx is equal to k. So, actually I need to find out the k. See, from here I can find k is equal to y by x. I can replace k is equal to y by x here. So, dy by dx is equal to y by x. Instead of k, I can write y by x. See, my dear students, I can take this is equal to, I can separate the variable. See, now I got an equation that is equal to dy by dx is equal to y by x. See, here this the equation 9 is the differential equation corresponding to the given family of curves y is equal to kx. So, dear students, this is the differential equation corresponding to the family. Now, the next step is we have to replace dy by dx to minus 1 by dy by dx. So, actually our thought is that have to find the family of curves which are very much orthogonal to this given family of straight lines. So, that we have to change dy by dx is actually representing, even if it is derivative, we can find corresponding to each and every points, we can find they are the derivatives, the slope of the tangent line. So, actually we have to replace the slope by the reciprocal of the negative slope. So, negative of the reciprocal of the slope, that is minus 1 by dy by dx. So, see, my dear students, here we have dy by dx is equal to y by x. So, instead of this dy by dx, I would like to write minus 1 by dy by dx is equal to y by x. See, here we will have minus 1 by dy by dx is equal to, see, minus 1 by dy by dx is equal to y by x. So, minus 1 by dy by dx. So, we can take the reciprocal. So, minus dx by dy. So, minus dx by dy is equal to y by x. So, dx by dy is equal to minus y by x. Dx by dy is equal to minus y by x. So, dx by dy is equal to minus y by x. So, that I can write dy by dx is equal to minus x by y. So, we can solve this differential equation. For solving this one, I would like to take this y to be here. So, y dy is equal to minus x dx is there. So, while solving that equation we will get y dy that is equal to, here this is equal to y dy, that is the integral of y dy. We already discussed in method of variable separable. We can separate the variables. See dear students, we can take the y to be here, therefore, y dy integral of y dy is equal to y square by 2. And similarly, minus x dx, integral of minus x dx is actually minus x square by 2. So, that my dear students, we will have x square by 2 plus y square by 2 is equal to sum c. Okay. Here come back to here the question, this is equal to here y square by 2 is equal to minus x square by 2 plus c. So, we will have y square by 2 plus x square by 2 is equal to c, that is equal to x square plus y square whole divided by 2 is equal to sum c, that is equal to x square plus y square is equal to 2c. That is, I would like to replace with another c, that is arbitrary constant x square plus y square equal to c. See here we got equation number 11. Actually, the equation number 11 is actually the equation of the concentric circle centered at origin 0 0 with a radius root c. So, these are the concentric circles that we discussed before, it is there in there. See, come back to this one. So, this is that one. Dear students, we already discussed here before, this is our equation. We have figure here, this is that figure. So, actually we took the family of the straight line passing through the origin. Now, the orthogonal trajectories are the concentric circle. So, my dear students, that is the way we can find. Firstly, if you have a family of curves, just differentiate that given family of curves with respect to x. After differentiating that family of curves, definitely you will have a dy by dx is there. Just replace dy by dx with a minus 1 by dy by dx, and you will get a new differential equation. You can solve that new differential equation. While solving that new differential equation, you will get the family of that one concentric circles here. So, that family of concentric circles are the orthogonal trajectories of the given family of the curves, that is a straight line passing through the origin. Now, so that we can say that the orthogonal trajectories of the family of lines through origin is given by 11. 11 is actually the concentric circles. And also, dear students, I would like to note that 11 is the family of circles with the centered at origin. Now, see, I would like to invite your attention to another example. In the new example, we will discuss about another question, that is the orthogonal trajectories of the family of the curves Cx square minus y square is equal to 1. See, dear students, this is Cx square minus y square is equal to 1. See, Cx square minus y square is equal to 1 is here. So, our aim is to solve this one. In the first step, we will differentiate with respect to x. Okay. While differentiating that with respect to x, we obtain, this is the derivative of Cx square, that is 2 Cx minus 2y into dy by dx is equal to derivative of 1 is equal to 0. So, we have this is equal to 2 Cx minus 2y into dy by dx is equal to 0. We can take 2, it is outside. So, we will get take 2 here. So, finally, we will have Cx minus y into dy by dx is equal to 0. Cx minus y into dy by dx is equal to 0. So, also, dear students, have to find the value of c. I would like to invite your attention again to our family of curves Cx square minus y square is equal to 1. We can take this is the y square to be here. So, we will have the value as this is equal to Cx square is equal to Cx square is equal to, we will have Cx square is equal to 1 minus y square is here. Okay. So, to find c, we will just take to x to here. Finally, we will have this value of c is equal to 1 minus x square, 1 minus y square, this is equal to 1 minus y square divided by x square is here. That is 1 minus y square divided by x square is here. So, fine. Now, we found c as 1 minus y square, this is equal to 1 minus y square divided by x square. So, dear students, we will have this is equal to, we have the value of c as have the value of c as 1 plus y square. Just a minute, I would like to just consider this is equal to minus y square, it to be 1 plus y square. Sorry, here this is equal to 1 plus y square. 1 plus y square divided by x square is the value of c. Fine. So, dear students, we found the value of c as 1 plus y square divided by x square is the value of c. That we can replace for here. We found the differential equation 2cx. Here we can replace for c. So, come to the next. So, we have 1 plus y square divided by x square is c actually. So, we have dy by dx is equal to, now we can replace dy by dx as come to be here. We have the differential equation is here, this is equal to this one, this is equal from here. See, here we will have this is equal to, we take to here. So, that will be 0. Finally, we will have the equation as cx minus y into dy by dx is equal to 0. Fine. Therefore, we will have from here, this is the from here we can say that y into dy by dx is equal to y into dy by dx is equal to cx. So, we already found the value of c. Therefore, we will have from here we can say that dy by dx is actually, finally we found dy by dx is actually is equal to cx divided by y, cx divided by y. This is actually dy by dx. So, this is actually dy by dx, cx divided by y is actually dy by dx. Now, fine, see cx by y is dy by dx we already found, therefore, dy by dx is equal to this one cx by y. Instead of c, we found the value of c as 1 plus y square by x square, 1 plus y square divided by x square. So, dy by dx is equal to cx divided by y is there. Therefore, this is equal to dy by dx is actually, this is equal to we have the value of c as, c came to the value of c 1 plus y square by x square, 1 plus y square divided by x square into y, the value cx is here. From here we can cancel x and x. So, finally, we will have, we can cancel 1 and x and x. So, we will have 1 plus y square divided by xy. So, that is here 1 plus y dy by dx is equal to 1 plus y square divided by xy is that dy by dx. Now, fine, we found the derivative. So, we will have dy by dx is equal to 1 plus y square divided by xy is the differential equation corresponding to the given family of curves. So, dear students, now we can replace dy by dx divided by minus 1 by dy by dx. So, we will get dy by dx divided by minus 1 by dy by dx. So, finally, we just replace this as the reciprocal. So, for dy by dx is equal to minus xy divided by 1 plus y square is. So, now we will get the differential equation. Now, we can take this is to be here and this is to be here. So, finally, we will have 1 plus y square dy is equal to minus xy dx minus xy dx. We are separating the variables. So, I would like to take this y to be here. So, we will have, dear students, we will have here, this is the here we will have 1 plus y square divided by y is here, y into dy, fine, y into dy, just a minute, y into dy is equal to now minus x dx. We separated the variables. Now, we can rewrite this as 1 plus y square divided by y into dy by dx is a sorry, 1 plus y square divided by y into dy, that is we can write this is equal to 1 by y plus y square by y is actually y, dy is equal to, sorry, dy is equal to, dy is equal to, dy is, sorry, dy is equal to, dy is equal to minus x dx is here, minus x dx, fine, minus x dx. Now, we can integrate, we separated the variables, now we can integrate. While integrating that one, we will get 1 plus y square integral of 1 plus y square divided by y dy is equal to minus integral of x dx. So, 1 integral of 1 by y plus y dy is equal to minus integral of x dx is here. See here this is equal integral of 1 by y is log y and integral of y is equal to y square by 2 is equal to minus x square by 2 plus the constant of integration, some C1 is here. So, we can rewrite this as log y plus y square by 2 is equal to minus x square by 2 plus C1 as 2 log y plus y square plus x square is equal to C1 is the orthogonal trajectory of the given family of the curves. Okay, my dear students, actually this is the way, through this way we are able to find the orthogonal trajectories of the family of curves. Firstly, we just represents the family of curves and after getting firstly we just differentiate with respect to x for the given family of curves. So, we will get the differential equation corresponding to the given family of curves and we then just replace dy by dx by minus 1 by dy by dx. So, we will get a new differential equation. While solving that new differential equation, you will get the solution of the new differential equation, that is the family of curves. That is the family of curves, they are orthogonal trajectories of the given family of curves, that we all, that is the method to find this is. And also I just I am giving some assignments to you, I will give you some ideas to solve this again. Find the orthogonal trajectories of the family of curves, y square equal to cx cube. See my dear students, as we done y square equal to cx cube, you can differentiate with respect to x. I this one give you you may solve this question as an assignment. So, find the orthogonal trajectories of the family of curves y square equal to cx cube, you may do this question as an assignment. Okay. So, dear students, you may just differentiate that one. So, while differentiating you will get dy by dx is equal to 3 c x square divided by 2 y. So, you can find the value of c as y square by x cube and just apply that y square by x cube is here. So, you will get a new derivative and you can replace dy by dx as minus 1 by dy by dx. Now, finally, you will get a new differential equation. You may solve that differential equation by integrating 3 y dy is equal to minus 2 x integral minus 2 into integral x dx. So, finally, we will get 3 by 2 y square plus x square equal to c1 is the orthogonal trajectories. I am giving one more examples to you, x cube plus 3 x y square is equal to c. So, you have to find the orthogonal trajectories of this family of curves. See, dear students, in this equation I would like to provide you as you may differentiate this one. Now, you differentiate after differentiation you will get this one another differential equation is here, that is dy by dx equal to minus x square plus y square divided by 2 xy, that is equal to f of x y. This is f dy by dx is equal to f of x y, is a function in x and y. See, this is while evaluating this one, you understood it is that this is homogeneous differential equation. See, the family of differential equation as homogeneous. Now you may replace dy by dx is equal to minus 1 by dy by dx. Okay, fine. Now you got a new differential equation, that is the equation number 25. In this equation number 25, you can find the orthogonal trajectories by solving that one. Now you can differentiate, this is like this, you just replace substitute x is equal to v y. Okay, that is y is equal to x by y. Okay, sorry, v equal to x by y, that is equal to x is equal to v y. So, you will get, you can as we did before, we already discussed how to solve the first order homogeneous differential equation, like that you can solve this. Okay. While solving that one, finally you will get the curve as y square minus x square is equal to c y. That is the orthogonal trajectories of given family of curves. I am giving one more question to you, sorry, I am giving one more question to you as an exercise. Again, find the orthogonal trajectories of the circles. X square plus y minus c square is equal to c square. For c not equal to 0, again I am giving one more question, find the orthogonal trajectories of the family of curves y is equal to x plus c e raised to minus x. Just do one more question as 2x square, find the orthogonal trajectories of the family of curves 2x square plus y square equal to 6cx. Now, again one more question is find the orthogonal trajectories of the family of curves 2y plus x plus c e raised to 2y is equal to 0. Okay. These are all the very nice and interesting questions from the solving the finding the orthogonal trajectories of the given family of curves. So, my dear student, this is a very interesting and nice applications of the first order differential equation. You may try to solve more and more problem. Definitely you will be motivated by the differential equation. It have very vast application in many ways of the many applied mathematics and physics and engineering and medical science, even in medical science also. Thank you for watching this video. Thank you very much. Thank you.